Section 2.2, Algebra of Functions. In the previous section we just saw an introduction to functions, domain and range, graph. In this section we'll be seeing how to add, subtract, multiply, divide, and finally we'll learn about the composition and decomposition of functions. And all these will show up in examples and applications and in the calculus part of this course. So adding, as we'd seen with polynomials earlier, we just combine like terms. The notation you'll see for adding is if you have two functions f and g, you'll see f plus g at x, which is the same as saying it's f of x plus g of x. If you have an f minus g at x, it's the same as f of x minus g of x. Multiplication, f times g at x. Again, this is not multiplication here. It's multiplication here, but this is just telling you what the variable is. It's f of x times g of x. Division is similar. F divided by g, the quotient of x, is f of x divided by g of x, provided g of x is not 0. You can't divide by 0. So those are pretty simple. The composition of two functions, it's f with a little circle of f circle g of x, is f composed with g of x, it's f of g of x. And you may need to do it in the reverse direction. You do the same thing, it's g of f of x. In calculus, you'll actually need to know, given the composition, what two functions are put together to get this. And so we'll see some examples of that. Something else in this section that's of big importance, as you will need this in calculus, is this guy, the difference quotient. We can abbreviate that as DQ, difference quotient. This is, difference means subtraction, quotient means division. So there's going to be a subtraction, f of x plus h minus f of x, all divided by h. This is the quotient part of it. And this, its importance will become pretty clear in a couple sections from now. So what we're going to do now is some examples on the worksheet from section 2.2 using these concepts. So here we have section 2.2 worksheet. You're given two functions, f of x, this is a linear function, a line, mx plus b, whereas this is cubic, g of x is x cubed plus 2x. Determine the following, f plus g at x, and as I said earlier, this is the same as saying add the two functions, f of x and g of x. Well, f of x is 3x minus 2, whereas g of x is x cubed plus 2x. So we have, put it in order, have x cubed, combine these like terms, 5x minus 2. And that's as far as we can go, so we'll stop there. For the next one, we have a subtraction. We have f of x minus g of x. And here you have to be a little careful, because when you have a subtraction and you have g of x, which has x cubed plus 2x, notice I put parentheses in there, and we need to distribute that negative sign. Now you can skip the parentheses and distribute the negative right away if you feel that you will remember to do that every time. Alright, so these two are now negative. Putting it in order, negative x cubed, combine like terms, 3x minus 2x is just x minus 2, and that's the answer. F times g at x, that's a multiplication. It's f of x multiplied with g of x. Well, f is 3x minus 2, g of x is x cubed plus 2x. Notice that I didn't say simplify, so technically speaking you could stop right here, but if you do choose to simplify you need to FOIL. Okay, so multiply those two, you get 3x to the 4th. 3 times 2 is 6x squared minus 2x cubed from here minus 4x squared. And this is slightly out of order, we can switch both of those, but this is good enough. Division, f of x divided by g of x. Okay, so this is f of x divided by g of x, and going here, that's 3x minus 2 divided by g of x is x cubed plus 2x. And there's no way you can do any simplifying because that does not factor anymore. We can't cancel due to the subtraction and addition, so you stop there. In the next problem, you're given two functions again. This is linear, this is quadratic, second degree. Determine fog, f composed with g at x. And what this means is it's f of g of x. So it's f of g of x is x squared minus 2x. What does f do? How does f act upon any input? If you have f of something, it's that something plus 5. So f of something, it's this something plus 5. And that's as far as you go. The second part, we have g of f of x. So it's g of, replace f of x, that's in here inside, with x plus 5. And then you ask yourself, how does g act? G takes any input, squares it, and subtracts 2 times whatever it is. So g takes any input, squares it, and does a minus 2 times the input. So in these empty spots, x plus 5 will go in. That's the input. Once again, technically speaking, we are done. We evaluated that. Question did not say to simplify. But if you choose to simplify, you do the FOIL there because you have an addition. So it's x squared plus 5x, and 5x is 10x plus 25 minus 2x minus 10. This negative sign distributes. And so we get x squared plus 8x. 10x minus 2x is 8x. 25 minus 10 is 15. Okay. This should also have been a review topic. Question 3 you may or may not have seen. Here you are given the result of a composition. Find f and g such that h is g composed with f. The answer may not be unique. So h is made up of two functions, g and f. So h of x is g of f of x. Okay, that's the order in which it's written. So f is the inside function. If you look over here, the inside function is that. So it makes sense that f of x is 2x minus 1. Which means g of x is the outer function, and x is its input. It's the square root of its input. So this is the answer. There's really no work to show. All the reasoning happens in your mind. But to check your work, you can actually do the composition. Find h of x. It's g of f of x, and f of x is 2x minus 1. And then how does g act? Well, it takes any input and puts a square root over it. Takes any input, puts a square root over it. And that's what was given to us, so it does check. Now it said here in the note that the answer may not be unique. That'll make more sense in the next problem. So here we have h of x is this, which needs to look like g of f of x. So we need an inner function and an outer function. The inner function could be 3x squared minus 1. The outer function could be 1 over x cubed. Could take whatever's in here and cube it to the bottom. Another possibility for this problem is we could have f of x to equal 3x squared minus 1 cubed, and then g of x could just take 1 over x. So you could do the check like I showed you earlier to see how both of these work, and there's actually even more possibilities, but I think that's good enough for this problem. The next question is going back to what I said earlier is called a difference quotient, and we had abbreviated that as dq. So to compute this, you have to find f of a plus h. Let's do that first. We're going to break this up a little, so we'll do this piece first. F of x is 2x minus 3, so f takes any input, multiplies it by 2, and subtracts a 3. So I'm going to put an a plus h in that spot. So you have 2a plus 2h minus 3. Now, this piece, f of a, well, let's just plug in an a for x, so it's 2a minus 3. Now the numerator, or the top part, you subtract those two. So you take this, 2a plus 2h minus 3, and you subtract 2a, the sign changes, so it's a plus 3. Now these wipe out, you get zeros, and you're left with just 2h. Now we're ready to do the entire problem. The difference quotient is, this is on the top, 2h, and you're dividing it by h. The h's cancel, so you get 2. That cleaned out really nicely. Let's see how the next one works out. Let's do the same thing. Let's first take this piece, f of a plus h. It's x squared minus 2x. So it's x squared minus 2x. So it's a plus h minus 2 times a plus h. You can multiply that out. A squared plus 2ah plus h squared minus 2a minus 2h. Distribute the negative sign as you go. The next part here is f of a, which is a squared minus 2a. It's simply plugging in a for x. And now if you look at the top, you're taking this minus this. So it's a squared plus 2ah plus h squared minus 2a minus 2h. This becomes a negative, that becomes a positive, and you distribute the negative sign. Simplify, simplify, and we have 2ah plus h squared minus 2h. So the difference quotient now is going to have this on the top. I'm going to divide it by h. Now it isn't legal for us to cancel the h's, but what we can do is factor out an h, which is a common factor, something we reviewed in chapter 1. So you have 2a plus h minus 2 divided by h, and now since this is multiplied to everything else, it is legal to cancel it. So our final answer is 2a, let me rewrite that, 2a plus h minus 2. Now the last problem is a business application, so hopefully you remember how this works from your economics class. If not, we will work it out. What you have here is a variable cost of producing X calculators is given, and the fixed cost is given. Find the total cost function C of X. So C of X, total cost, is fixed cost plus variable cost. The fixed cost is $1,500, just to make any number of calculators. And this is for all X calculators, the variable cost, so it's just 300 minus 2X. It's not saying it's the variable cost per calculator, it's for all X calculators. So we can combine like terms and we get 1,800 minus 2X. Okay, now we need to find the next function called the revenue function. If X calculators are sold and each calculator is sold for $60, so one calculator, $60, two calculators, 60 times 2, X calculators, 60 times X. So the revenue function, we call it R of X, is 60X. Finally, profit function. You may recall from economics that profit is revenue minus cost. So it's R of X minus C of X. R of X is 60X minus cost. Now cost has two terms, so either distribute the negative or put parentheses because it has two terms. Distribute the negative now, and it becomes a positive 2X. Simplify your answer, I've said. So add those like terms, 62X minus 1,800. Okay, hope this helps. Try the homework. Let me know if you have questions.